You can do machine learning with 3 functions, and they're all in the Scikit-learn library, also known as Sklearn. I'm going to explain each function, and then at the end of this video, I'm going to show you how you can use them all with different machine learning algorithms. Let's go. The 3 functions are train, test, split, fit, and predict, and that's the exact order that you use them in projects. Let's start with the train, test, split. This allows you to split your datasets into 2 different subgroups: the training dataset and the testing dataset. In machine learning, it's good practice to train your algorithm on separate data than what you test the algorithm on. Think about if you were a professor creating an exam for someone. You wouldn't want to give them the same exact questions that they had in their homework. That wouldn't be a good test. All right, let's look at some code to better understand it. You can see here is the function. In order to use this function, I first have to import it from Sklearn's model selection library. Here you can see an example dataset where each array is a different row in our dataset. And now when we use the function, all we do is pass in our dataset, specify the size that we want our training dataset to be. You can also specify the size of the test set, but here I do the train set. And then that will split the data into these 2 separate data sets you see on the left. The training set will have 70% and the test set will have 30%. Let's see what that looks like. There you go. The training set got rows 1, 3, and 2, and the test set got rows 5 and 4. Now, one interesting thing with the train test split is that you can actually pass in multiple data sets and it will split them all for you. Let's look at that. So here I have 2 data sets, X and Y, and you can see that I'm passing both of them in. So what that does is it first splits the first data set into 2 variables, and then it splits the second data set into 2 variables. So when we do our predictions, we're going to use the training data to fit our algorithm, and then the test data to evaluate it, which we'll see more in a little bit. Now let's see what this looks like. There you go. So one thing I want you to notice is that the train test split function keeps the different rows from each data set together. You can see here that the first value of X train is the same as Y train. The next value is 1, this one's 1, this one's 3, this one's 3, this is 4, 4, 5, 5, etc. This is important because when we pass our training data into the algorithm, we want the rows to line up, so it knows that this row corresponds to this value here. Same for the test set. I use the variables X and Y here because in machine learning, typically X is used to store the features and Y is used to store the labels. For example, the algorithm will make a prediction using this data, and the correct answer is 1. And same for all the rows. Y represents the correct answers, and X is the data that we're making predictions from. Now let's talk about the fit function. After instantiating an instance of your algorithm in code, you can then call fit on it to train it. This is when the algorithm learns from the data. Typically, it's going to learn from the training data that we just created using the previous train test split function. Let's take a look. Here you see I've imported the logistic regression machine learning algorithm. I create an instance of it, and then on that instance, I call fit, and I pass in the training data. It's as simple as that. And lastly, predict. Now that you have a fitted algorithm, you can call predict on it to make predictions for new data. Typically what you do is you pass in the test data, create a bunch of predictions for it, and then compare those predictions to what the actual values should be in order to evaluate how well your algorithm performed. Let's take a look. You can see here that I'm passing an X test into the algorithm's predict function. Now we have predictions. If you've been finding this video useful so far, then you'll probably benefit from a free PDF that I have on my website. You can head there to download it. In the PDF, I explain all the fundamental machine learning algorithms, and I have their implementations in Scikit-learn code. Link is in the description below. All right, now let's see these 3 functions in action by looking at some examples. I want to direct your attention to this line. In this example, we're going to be using the Titanic dataset to predict whether or not passengers survived. And we're going to only use the feature of sex, which is the passenger's gender. Going back for a second, here is where I'm doing a lot of the imports of libraries that we'll need for this project. NumPy and Pandas are some basic machine learning libraries for statistical analysis and manipulating data. This is the train test split function that we already talked about. And here are 3 different machine learning algorithms that we'll be using. Going back to getting the data, I use pandas to read the data in, and then on this line, I change the sex from male and female to the numbers 0 and 1. We need to do this because machines don't understand words like male and female. Everything needs to be converted into numbers. Let's take a look at this data. There we go. Here you can see a female that survived. Here's a male that did not survive. Let's get another sample. Here is a female that did not survive and a male that survived. All right, like I mentioned earlier, by convention, X is used to store the features and Y is used to store the values that we're trying to predict. So I'm going to set that up here. And that's all the setup we needed to get to the 3 functions. Let's start with train test split. I'm going to pass in X and Y to get our training data and then testing data. Here, I'm going to call the fit function, passing in the training data to fit our logistic regression algorithm. Now, I'm going to create predictions using the test features. And here, I'm going to compare these predictions from the test features to the correct values from the test set. This is going to sum up all of the ones that match and then divide by the total number to get an accuracy. So let's see how well our logistic regression algorithm performed. 78%, not bad. That was logistic regression. Let's see how easy it is to use a different machine learning algorithm. All I'm going to do is uncomment this, comment this out, train test split, fit, predict, evaluate. 77%. Let's do it again. Train test split. Let's do a decision tree, fit, predict, accuracy. I hope you can see how simple it is to train machine learning algorithms in Scikit-learn. If you enjoyed this video, then you might enjoy the video on the screen where I use deep learning to classify images of muffins and chihuahuas. See you in the next video.